Okay. Here we'll be proving that if we have the matrix AB and we take its transpose, then this is equal to the product of B transpose times A transpose. So I'll begin by assuming that A and B are matrices such that they can be multiplied. So of course, not all matrices can be multiplied. I'm not going to write it down because it's quite evident. Like obviously, we're not looking at matrices that can't be multiplied. So for starters, before starting the proof, I'm just going to write down the definition. So what does it mean for A, B, T? This means that if we take the ij element in the transpose of AB, this is equal to ABJI. So actually, for this proof, I'll use K. Why not? So equals KI. What does B transpose T mean? B transpose T means that the I element, the IK element in B transpose T is equal to BKI. And then the final definition I'm going to write down is just the general definition of multiplying two matrices. So this should be quite simply AB IK equals, and let's use J equals 1, AJI, I think, no, IJ times BJK. So how do we play with this? For starters, let us use, um, so I'm going to prove this from the right-hand side to left-hand side. But once you see the proof for this, you can all obviously go backwards, back and forth. It doesn't really matter. So by the matrix multiplication definition, BT AT is equal to, or well, the IK element is equal to, let's use J equals 1 again, is equal to BT IJ times AT JK. Not. This is just writing out the definition of matrix multiplication, which you can see over here. So what do we do with this? Well, by definition, BTIK, so the transpose of B, and if we look at each element in the transpose of B, it's equivalent to B with the element's inverse. So instead of IK, it's KI. So let's just rewrite everything, but get rid of the transposes. This should be J equal 1 N B J I times A K J, right? Because we're just using this definition over here. Uh, since B and A, since a specific element within the matrix B and A are real numbers, we can swap the A and B because by definition or by associativity, AB equals BA for any real numbers, for any real number, right? So like 3 times 2 equals 2 times 3. So we'll just swap everything just to make our life easier. We have AKJ times BJI. Now, by definition, by the matrix definition, of course. So this over here, you can see that this over here is literally just this, but we swapped the I and the K. So this means that this should be equal to, this whole blob should be equal to A B Ki, right? Because we have this entire thing right over here, but with the K and I's inversed. And well, when we have this, we have ABKI. Do you remember how we defined the transpose of ABIK to be equal to ABKI? So by definition, this is equal to ABIK. Quite, quite simple. So as you can see, we have proven it. You could do this backwards. So you could start with this,